This is Algebra 2, Unit 4, Lesson 1 on integer exponents. In this unit, we're going to be working with exponents, so let's review, first of all, what integer exponents are. Integer exponents are positive or negative whole number exponents. We learned these back in Algebra 1, so let's see if we can review how we use them. All right, let's start with the powers of 3, for example. Now we know an exponent by definition means to take your base and multiply it by itself the number of times the exponent says. So if I have 3 to the 1, that just takes 3, multiply it 1 time. 3 squared would be 3 times 3, so 3 squared is 9. 3 cubed is 3 times 3 times 3, which would be 27. Okay, so every time we go up, we're multiplying by another power of 3. All right, so let's do a little figuring here. If this is 3 to the 1 gives me 3, what was multiplied before that? Because this is 3 to the 0, what times 3 will give you 3? Well, it would have to be 1. So any value raised to the 0 power is always 1. Okay, so if we're working backwards, or working through here, we're multiplying by 3. What if we're going in this direction? What are we doing? We are actually dividing by 3. So if we are dividing by 3 here, as we go into the negative area, this could actually be rewritten as 1 over 3 to the 1. So that's going to be 1/3. Following that idea, what would 3 to the negative 2 be? It would be 1 over 3 squared, which would be 1/9. And then this would be 1 over 3 to the 3rd, which is 1 over 27. So we can see the pattern here. As we move to the positive direction, we're multiplying by 3. As we move in the negative direction, we are dividing by 3. So a negative exponent can be thought of as a division. And it's fraction, basically. You want to do the reciprocal and make the exponent positive. So as a quick review, when we are doing integer exponents, when you have b to the n, you start with 1, and then you multiply however many times b. So 1 times b multiplied to whatever times. All right, so that is a positive exponent. B to the 0 is always 1, no matter what. That would be this term right here, would be the 0 term. That would be b to the 0 is equal to 1. And a negative exponent, basically, it's 1 over b multiplied that many times, so it's 1 over b to the n. Okay. Let's take a look at some examples. Given the exponential function f of x equals 20 times 2 to the x, evaluate each of the following and show your calculations. So f of 2 means take 2 and plug it in. So 20 times 2 squared. All right, order of operations, do the squared first. So this is going to be 20 times 4, which is 80. All right, f of 0. 20 times 2 to the 0. What is 2 to the 0? It's going to equal 1. So 20 times 1 is just going to be 20. Okay, negative 2. F of negative 2, we plug in, is 20 times 2 to the negative 2. All right, now how do we rewrite 2 to the negative 2? Well, 2 to the negative 2 is 1 over 2 squared. Whoops. So 1 over 2 squared is 1/4. So 20 times 1/4 is equal to 5. So when you're doing a negative exponent, just flip it, make the exponent positive. All right, now in this problem, when x increases by 3, by what factor does y increase? And explain your answer. Okay, so let's look at that. What is f of 1 if we work this out? It would be 20 times 2 to the 1st, which is 20 times 2, which is 40. And then f of, well, if x increased by 3, that would be f of 4. Let's see what that is. 20 times 2 to the 4th. All right, 2 to the 4th is equal to 16. And 20 times 16 is 320. Okay, so if f of 1 is 40 and f of 4 is 320, we've increased the x by 3. The factor of y is multiplied by 8. Is multiplied by 8, and that makes sense when you think about it. Because 2 to the 3rd is equal to 2 times 2 times 2. So we increase the factor. We started by 3. We are multiplying it 3 times, and it increases it by a factor of 8. All right, now let's review our basic exponent laws as well. Let's write the product as a single exponential expression. And if we need to, we can write it as extended products if we need to figure it out. Okay, 2 to the third times 2 to the fourth. When you multiply the same base, what do you do with the exponents? You add them. All right, because it would be 2 to the 3 plus 4, which is 2 to the 7th. Now, why is that true? Because 2 to the third is actually 2 times 2 times 2, times 2 to the fourth, which is 2 times 2 times 2 times 2. 1, 2, 3, 4, 5, 6, 7. That's why that's true. 2 to the 6 times 2 squared is 2 to the 8th. 6 plus 2 is 8. So the general rule, 2 to the m times 2 to the n, will be 2 times m plus n. Now, this works for all positive integer exponents, but it also does negative exponents. All right, now let's look at the product 2 to the third times 2 to the negative 1. All right, if we use the exponent law that we were just talking about, all right, 2 to the third times 2 to the negative 1 would be 2 to the 3 plus negative 1, which would be 2 squared. All right, and that's equal to 4 if we worked it out. All right, now, why does this work? Let's rewrite this. 2 to the third is 2 times 2 times 2. 2 to the negative 1 is 1 half. All right, well, let's see. 2 squared we said was 4. 2 times 2 times 2 is 8 times a half is also equal to 4. So you can see when you're doing this, if you're multiplying the same base, you add the exponents, this is actually what you're doing. So do your answers from A and B support the extension of the addition property of exponents to negative powers as well? Yes, because A and B are equivalent. We got the same answers by doing it using the addition property and by writing it as extended products. So because A and B are equal. So that is true. We got the same answer doing it both ways. Okay, let's look at another exponent property. This is a shortcut property, and it's an extension of the addition property of exponents. When you have the same base, you add the exponents. All right, let's look at the exponential 3 squared raised to the third power. This is raising a power to a power. Do you remember what the rule is? Well, let's write its extended products and see if we can figure it out. 3 squared cubed says to take 3 squared and multiply it 3 times. So this actually means 3 squared times 3 squared times 3 squared. Well, multiply the same base, what do you do with the exponents? It's 3 to the 6. You add the exponents together. Okay, now there's got to be a faster way than having to write that out every time. You wouldn't have to go 3 squared, 3 squared, 3 squared. Well, isn't that 3 to the 2 times 3? Yeah, it's equal to 3 to the 6. All right, so if I know a power raised to a power, it's telling me to multiply the base this many times, just multiply the exponents. Okay, so 3/4 squared would be 3 to the 4 times 2, which is 3 to the 8th. All right, because it's really 3 to the 4th times 3 to the 4th, which is 3 to the 8th when you add them together. Power to a power is a shortcut. Okay, so the general rule is 3 to the m raised to the n power. It would be base of 3m multiplied n times would be 3 to the m times n. So it's really important to be able to distinguish when to add the exponents and when to multiply the exponents. All right, let's look at the product property of exponents with negative exponents. Consider the expression 3 to the negative 2 to the 4th. Show this expression is equivalent to 3 to the negative 8th by first rewriting 3 to the negative 2 in fraction form. Okay, so 3 to the negative 2. What is that equal to in fraction form? Well, it's equal to 1 over 3 squared. Okay, and that's equal to 1/9 if you want to work that out. Okay, so if we have 3 to the negative 2 to the 4th, that actually means take 3 to the negative 2, and I'm going to multiply it 4 times. And they're multiplied 4 times. We have negative 2 plus negative 2 plus negative 2 plus negative 2 is 3 to the negative 8th. So instead of having to write this out like this, if we know this rule, 3 to the negative 8th, that's going to give me negative 2 times 4 would be 3 to the negative 8th. So it does work. So to save yourself having to write this out and add them together, just say negative 2 raised to the 4th would be 3 to the negative 8th. So it works. And we've got the values. All right, so remember this is actually, if you want to write this even farther out, it's 1 over 3 squared, 1 over 3 squared, 1 over 3 squared, 1 over 3 squared, and that's equal to 1 over 3 to the 8th, which is equivalent to this. All right, so that's a quick review of the rules for exponents. Positive exponents and negative exponents. When you're working with positive integers, it's multiplying. When you're doing negative integers, it's dividing. When you have multiplying the same base, you add the exponents. When you're raising power to a power, you multiply the exponents. So this should all be very much review. It's stuff we did back in Algebra 1, but I want everybody to understand those rules as we move forward.